Hello YouTubers, welcome back to my YouTube channel. Uncle Pythagoras signing in. Today we are going to do grade 12 mathematics. We are going to do the inverse function. Right, we know that there is an inverse function, but there is a function before the inverse function. Someone can want you to define the definition of a function. What is a function? A function is a rule by which one element of a domain is associated with only one element of the range. When we talk about range, we talk about y. The range is y. And when we talk about the domain, we're speaking about x. Speaking about x. Let me just make an example so that you will understand. For instance, we are given the equation. Maybe you can take an equation that goes like f at x is equals to 2x plus 1. In every element of x here, we're going to get that. Let's say x is equals to 1. F at 1, it is equals to 2 multiplied by 1 plus 1, which is 2 plus 1, which is 3. So x maps 3 in the range. The domain of 1 maps the range of 3, and then f at 2 is equals to 2 times 2 plus 1, which is 4 plus 1, which is 5. Let's check the last one. When x is 3, our y is going to be 2 times 3 plus 1, which is 6 plus 1, which is 7. Now, in order for you to explain what is the function, you are going to have a set of the domain. The domain, remember, it's x, maps the range. The range in this case is 1. When x is 1, your y is 3. When x is 2, your range is 5. And when it is 3, it maps 7. Now, this is the practical example of the function. They said one element of the domain is associated with only one element of the range. This is a perfect example of the function. So in this case, there is no value of x which can maps two values of y. It's only 1 is to 1. This condition is called 1 to 1 function. it is a function. Right, let's check another condition where we have two values of x. Like for instance, we are going to say many to one function. This is a one-to-one function. Let's check many to one function. This is the example of where you have a parabola where you are going to get f at x equals to x squared. In this case, you are having two or many elements of the domain maps, or it is associated with only one value of the range. In this case, your range is y and your domain here is x. Two or many, rather let's restrict this one. One or many, let's go for that. One or many, or one or two elements of the domain maps with only one value of the range. But it's fine like that. So let's do the example here. We are going to have f at x is equals to x squared. In this case, we are going to have the value whereby we have a table of x is to 1. Now let's say here you have let's say here you have a 1, you have a 1, you have a 0, you have a minus 1. Then if you take a minus 1, you put it in this f at x equals to x squared. You put minus 1 squared, you're going to have a 1. You put a 0 here, you're going to have a 0. Then you put a 1 here, 1 squared is 1. You see now, you've got minus 1 value of x which maps with 1. You have a 0 which maps with a 0. You have a 1 which maps with a 1. Here you have two values of x, a minus 1 and 1, which maps with exactly one value of y. Hence we say two elements of the domain maps or associate with only one value of the range. Only one value of the range. We have a 1. Let's just do the element set to see what we are talking about. Right? You have this set of elements of the domain it's x, and another set of the range. The range, remember, it's associated with y. Right? They have a 0, 0 is associated with 0, and a 1 is associated with negative and positive 1. Now this is the perfect example of the many to 1. Many to 1. Many elements of the domain associate with 1 or maps to 1. And this is the only element which maps 1 and 1. But this one, it's 2 elements, 2 maps with 1 element of the range. This is the perfect example of the function where you have a many to 1, and this one has got a 1 to 1, because every element of the domain is associated with the range. Right. If we come here to define a function and what is not a function, if you want to see what is not a function, we are going to grab this very equation of f at x is equals to x squared. Now, if we want to find the inverse of f at x, we are going to say, remember matrix, f at x, you must always equate it to 1. F at x is 1, y is equals to x squared. Right, when you do the inverse, you simply swipe the values of x and y. Where you see y, you put x, and where you see x, you put y. So instead of y here, I'm going to put x is equals to y squared. Now this is the function whereby we have the inverse of f at x. Now this is going to be f at x, but let's make the y the subject of the formula. Then y squared is equals to x, then a square root of y squared is equals to a square root of x. You cancel a squared with a square root, you are left with y is equals to plus minus a square root of x. Now this is in the form of the inverse function is equals to 1 negative dash x is equals to plus minus x. Now this is going to be our inverse in the form of f at negative 1x. This is the inverse. Now, if this inverse is going to be true and only true when it is going to be restricted, only when you restrict, you are going to tell them that you cannot have a negative value of x, because once you have a negative value of x, what is going to happen? You are going to have an imaginary. So a square root of a negative number is undefined. So in order for us to avoid the undefined situation, you restrict your x. X must be greater or equals to 0. In other words, it must be 0 or it must be a positive only in order for this to hold water. Now, this, if we were going to put it on the table, remember, where you see x, you put y. Where you see y, you put x. Tables have changed. Tables have turned now. This is your y. Then you have your 0. Excuse me. your minus 1, your positive 1. Then if you put, rather let's not swap because we have represented this as f at x. Let's just remain as x here and remain as y here. This is just an illustration. We are coming to do the examples where you will see how do we swap the values of x and y. But for now, let's use the value of y as that. Now the value of y is going to be, if you put your 1 here, you are not going to use a negative because we said x is greater than 0. So this clearly is going to be cancelled. We are going to use this one. So in order for you, at 0 is 0, and then at x is 1, your y is plus minus 1. You put your 1 here. Here is your 1. X is 1. You are going to get that f dash x is equals to plus the square root of 1, or f dash x is equals to minus the square root of 1. If you check here, you have your 1 here, you are going to get a plus 1. You have again your 1 here, you are going to get a negative 1. Why this is going to be plus minus? Because there is a plus part and there is a minus part. Now this is what we call many to 1. 1 to many, sorry. It's 1 to many. You have one value of x which maps many values of y. It is plus or minus. So if we can put this into the elements. Let's put the elements of x here and the elements of y here. This is your domain. Domain is represented by x and range, which is represented by y. Now we have 0 and 1. 0 maps with a 0 and 1 maps with minus 1 plus 1. You see, 1 to many. One value of the domain maps to value of the range. Therefore, we can conclude to say that this is not a function. This is not a function. We are going to grab some few examples to illustrate where we have no function and we have a function and we also have a function. Let me just stipulate here. This is a function. And also this is a function. But this, the one that is the inverse, is not a function. Then we are going to explain it furthermore in the next videos. For now, you can just go and practice this and understand what we mean by a function. You need to know what is the definition of a function. You must know why we call a function that it does not qualify to be a function. So we're going to do the illustration with the few examples that we're going to grab in the next video. Thank you very much, grade 12. Uncle Pythagoras signing out. We'll see you in the next video where we have to explain some more about the function and not a function and how do we find a function. Uncle Pythagoras signing out. Thank you very much, grade 12.